We are talking here today about the upper 700 megahertz A block, which is now also designated by 3GPP as band 103. My name, by the way, is Bob Finch. I'm president of Select Spectrum. So in terms of this block, it is in what many people call beachfront property, prime communications capability, operating between Verizon and AT&T FirstNet. What that means is there's a tremendous amount of amplifiers, antennas, all of the basic RF equipment available for this band. And historically, there has been a MIMO-MAX industrial radio product as well. Now we also have, as I'll be talking about today, Ubiik is offering a band 103 NB-IoT product. So you see here, it's excellent communications territory. This is regulated by the FCC, but they offer very generous power limits, up to 30 watts on the uplink, 1,000 watts on the downlink ERP. This is a total of 2,000 kilohertz, right? 1 megahertz plus 1 megahertz in paired configuration. Sometimes I call this the Boeing band, 787 to 788 and 757 to 758. What many parties will do will choose to divide this frequency up into narrower channels. But in the NB-IoT configuration, you would use a full 200 kilohertz channel for each NB-IoT block. I'll talk a little bit more about that later. All right, this band has been particularly attractive to utilities. So we're here at Distributech. Many utilities are using this already in their electric distribution networks. We see it in gas and water utilities as well. All of the blue areas on this slide, over 20 utilities across the country, covering about a third of the country so far, are using this spectrum band. Many of them with MIMO-MAX equipment, and we think increasingly we'll be seeing the Ubiik band 103 equipment as well. The most recent sales here, by the way, that happened within just the past few months are to National Grid, covering the entire state of Massachusetts, and to Avangrid, covering so far a portion of the state of upstate New York in the Rochester area. And we're hopeful there'll be more acquisitions of this spectrum coming soon. It's in all of the places where it's shown in green on the slide, it's still available for purchase. And we have utilities who are actively seeking it out now, and more excitement as additional capabilities come into the band. All right, so we should talk about what's the difference between what I call industrial radio and NB-IoT. So NB-IoT is a standard that was developed out of the cellular industry. The Standards Association is called 3GPP. They set the standards for all of the cell phones that we use, and they also have set standards for narrowband Internet of Things. So this is a particular technology that's designed to have low-cost end devices, potentially thousands or tens of thousands of endpoints per base station, millions across the coverage area for a particular utility. It's designed for very long range, and therefore is quite economical. It can be operated in a battery mode as opposed to needing to be charged. Batteries could last 10 years or more, depending on how often the device wakes up and transmits. And the chipsets can be very low cost. So that's how they can get to an economical solution over tens of thousands of endpoints and potentially millions for a given utility. I mentioned 3GPP. This is the standard organization that supports all of these frequencies and all of the operations of cell phones, both public, right? So this is the AT&Ts and Verizons that we all know about, and private. The private networks are becoming increasingly popular, and 3GPP has modified its standards to also support these bands. So you see here, this has been approved and sits in the middle of the very valuable 700 megahertz block overall. It's heavily used by the carriers. So in terms of milestones, certainly worth talking about what's been happening here. In April of 2022 was the first announcement of this band being approved by the 3GPP organization. and it was included in release 17.5. In January 2023 is when Ubiik and Realtek announced the Nimbus 220. That is a module that can go in a wide variety of devices. It's not the only module on the market, but we're very excited to see this one coming to market. And what's happened in general in the private network space is, as these standards-oriented systems are coming into place, it's allowing a wide range of endpoints. Could be meters, could be streetlight sensors, gunshot sensors, parking systems, traffic lights, a wide range of capabilities that can be used with these systems. And just January of this year, Ubiik has announced that the FCC has approved their module, and so it's available for incorporation in terms of any of these devices. So let's talk about the types of applications that are coming in the narrowband world. We see them in public safety. You can imagine a situation where every fireman or policeman has a wearable device on their uniform and keeps track of them, has a man-down type sensor. We're, of course, in a utility show. We're seeing interest in this, not just for electric meters, but water and gas, to help sense for any loss of either water or methane. So great capabilities that are coming here. And one of, as here we're in Florida, rooftop solar is becoming increasingly common. It's very important to monitor those devices. The Salt River Project is an example of a company, Salt River Project based in Phoenix, is monitoring their rooftop solar using the upper 700 MHz A Block and MHz equipment. And then smart grid, smart city type applications are coming rapidly as well. You see that the forecasts are for 20+% annual growth in this market. We're seeing certainly more interest, great expansion of the types of devices. I've had several good conversations at these shows, at this particular show over the last day or so, with entities that are doing smart grid and smart city. I'll give one example. This is from Itron, a giant booth here, a highly respected company, and they're talking about how much money can be saved, how much excess carbon emissions can be achieved using IoT streetlights. So why would this make a difference, right? A streetlight, you would think, is not that intelligent device. But in fact, the new streetlights, they will sense when they need to be maintained. They can be turned up or turned down, either on a schedule, or if there's an incident in the area. You can imagine a situation where a gunshot is sensed, the lights automatically come up, and a harmful situation can be easily averted just because the lights come up. So lots of enthusiasm in this. We see that an example city implementing this kind of solution could save over $100 million over the 15-year life of the system. That would more than pay for not just the lights, but also the actual system to monitor and control them. So you can see the economics of this. And on a global basis or a national basis, this is millions or billions of dollars in savings and carbon avoidance of carbon emissions as well. And so this is an example. If you're interested, Itron has on their website a calculator that can show you what the benefits are of this technology. So what does it take to build these smart grids? It takes standards. I talked about the standards. It takes chips and modules are, for example, being produced by Ubiik, MHz, an excellent example of that. It takes integration services. You need engineering either from a company like Ubiik MHz or from one of the engineering firms that's here. And then I saved the best for last. It takes spectrum, right? You have to have the ability to transmit. There are solutions using, and Ubiik has a solution using unlicensed spectrum, but in general, in many environments, congested environments, in environments where you need longer distance, there's significant advantages to having licensed spectrum. So we highly recommend you check out Band 103. We're here by the way, in booth 1613. If you want to talk with me separately, I'm going to stay for the happy hour, which is coming up very soon. Don't forget also to subscribe to our YouTube channel. SelectSpectrum.com is our website. Thanks very much.